Hello and welcome back to P Academy. So this is example 5 super mesh. So we looked at 4 examples so far. So if you are just coming across this, the other 5 videos under super mesh, please I'll leave the link in the description of this particular video. You can also check the links for videos under series like mesh, super mesh, nodal analysis, stevening and the likes. Alright, so now let's look at this example 5. We have this diagram here, this circuit, and it said that we should find the current in each mesh and the current in each element. So you're going to look, we have 1, 2, 3 mesh, and then we are going to look for the current that is in each of these elements. That means in these resistors, what are the current that are flowing through it. So if you have been following this video from the beginning under super mesh, I want to believe this should be a bonus question for you. So what I want you to do for me is to just pause this video, attempt it, note down your answer, and then you look at the solution. So just to test your knowledge, so just pause the video and then try to attempt. It's a very simple one. That is, if you have watched the last 4 examples, I want to believe this should be a bonus questions for you. Alright, so now let me just go ahead and solve it on my own. I want to believe you've also gotten your own answers. And then, and if you got your answer to be probably 3, 3, and then -1, that means you are correct. But anyway, let's just go ahead and solve it. Alright, so now we have this now. Let's solve. Alright, so the first thing that we have to do is to do what is to pick our direction. So let's pick our direction. So like I do, clockwise for everything. So let's take this to be I1, I2, and then I3. So that means the current flowing in this particular mesh is I1, this is taken to be I2, and this is taken to be I3. So now once that is being done, so let's take our polarities. So the polarities for the voltage source is always constant. This is plus, this is minus. Why for this is plus, minus. That means in this direction, I'm going in this direction, this will be plus and then minus. We'll come across plus first before the minus. So that is how you give it the polarities. For this will be plus, minus, plus, minus. And then for this will be plus, and then this will be minus. Alright, so with that now, let's write out the equation for of the current source. So let's do that here. So let me just draw it somewhere here. So we have this is where the super mesh comes into place, where we are having a current source between 2 meshes. So this one is coming downward, and we're given to be 4 amperes. Is that clear? So the two currents flowing through it is I2 and I3. So I2 is coming downward, and then while I3 is like this, going upward. So this is I3 and this is I2. So with this now, we can already get our equation of our current source, which will be what? So if you have been following, what would that be? I2 minus I3, and which is equals to 4 amperes, and this is our equation 1. So that we've gotten our first equation. So the next thing we have to do is to draw a super mesh circuit. So for us to draw a super mesh circuit, so in doing that, we are going to be drawing this. So that means we are going to be having something like this. So we are going to be omitting this particular branch where we are having the current source. So here we are having a 10 ohm resistor. Here we are having 5 ohm resistor, and here we are having 15. So we are having 15 ohm, not 15 amperes. So 15 ohm resistor. So let's bring back the polarities that we are having here. So on this part, this 10 ohms, this is it here. We are having plus and minus due to a current flowing in upward direction, which is I2. We also have on this side a current that is flowing downward, which is I1. And then the polarity is what? Plus here and minus here. This is it here. And for this, we are having plus and minus due to a current I2. The current is what? Is I2. So it's only I2 that is flowing through this. There is no other current flowing through the 5 ohm resistor. And for the 15 ohm, we have I3 flowing in this direction, downward. And the polarity there is plus and minus, downward like this. Alright, so this is our super mesh circuit. So the next thing is, let's apply Kirchhoff voltage law. So if you should apply KVL, to super mesh. So what we are going to be having, so let me just start from this particular node. and then we go round. All right, so this is so from plus to minus due to I2, we are dealing with a 10 ohm resistor, so that's going to be or let's just say from minus to plus, so that will be from minus to plus now is due to I1, so that we're going to be having 10 I1. Don't forget from minus to plus, so we are sticking with the plus, that's like plus 10 I1. So then the next one is from from plus to minus, so that will be minus. So from plus to minus, we are ending in minus, so that's why it's minus first, so that will be minus 10 I2. Then we get here, that's from plus to minus, that's minus 5 I2. Then from plus to minus, that's minus 15, and then the current here is I3, so let me indicate it, I3 minus 15 I3. All right, then there's nothing here, so we get here, that's equals to 0. So with this now, let's just simplify it. That's 10 I1, then minus 10 I2 and minus 5 I2, that's minus 15 I2 minus 15 I3. I hope you can still see this. Minus 15 I3 equals to 0. This is our equation 2. So that's equation 2 right there. Okay, so now let's apply KVL to this particular mesh 1. So apply KVL to mesh 1. So where we are having I1, so if you should apply KVL to mesh 1, we are going to be having this. So let's start from this point here, and then we go around the circuit. So from here, the first element we are coming across is the voltage source, and it is from negative to positive. So that's just 2, and it's already in volts. So we can go ahead and write the value straight away. So that's 2. Now from plus to minus, that will be minus 1, and then the current there is I1, minus 1 I1. So you can also write minus I1, it's still the same thing. So the next element we are coming across is this 10 ohm resistor. So from plus to minus due to current I1, so that will be minus 10 I1. And also from minus to plus due to current I2. Remember, this 10 ohm resistor, there are 2 currents flowing through it, I1 and I2. So that will be plus 10 I2. So we'll continue, and then we'll come back to where we started from. There's no other thing there, and then we'll see equals to 0. So let's simplify this. We're having minus 1 I1 and minus 10 I1. That's minus 11. 11 I1 plus 10 I2 equals to minus 2. So this is our equation 3. So what we are going to do next is to solve equation 1 and equation 2, equation 3 simultaneously. So let me write it out the way I used to write it out, so I can just use my calculator to get the values. So here, this is equation 1. We're having I2 and I3. We don't have I1. So we can just pick it as 0 I1 plus 1 I2 minus 1 I3 equals to 4. And then equation 2, we have it to be 10 I1 minus 15 I2 minus 15 I3 equals to 0. While for I3, we are having to minus 11 I1 plus 10 I2. So we don't have I3, we can just give it either plus or minus. Is 0 I3 equals to minus 2. This will still give us a 0. So the reason why I'm doing it like this is so that if you want to use your calculator, you can easily do that. So let's just go through it again. So if you have your scientific calculator like the Casio 991, so once you press the mode button 3 times, 1 2 3, you see equation, you press 1. Unknown, there's option for 2 or 3. So if you look at this, we are having 3 unknown, I1, I2 and I3. There are 3 unknown values. So you press 3, and then it brings you this. So it asks you A1. The value of A1 here is 0. So you press 0 on your calculator, press 0 and equals to. Then the next thing, to ask you for B1. B1 is the next value, which is 1. So once you press 1, it will ask you for C, which is minus 1. So always look at the one with negative, you pick it, you input it in your calculator with the negative, so that is minus 1. So minus 1, you press your equals to. To ask you for D1, our D1 is 4. Press your 4, your equals to sign, and then you go to the next line, which is A2. A2 here is 10. So once you press 10, your equals to sign. It asks you for B2. B2 is minus 15. If you check it here, minus 15. So you press minus 15 on your calculator and your equals to sign. So you continue in that manner. For C2 is also minus 15. Then it's asking for D2. D2 is 0. I press 0 equals 2. Now it's asking for A3. That's coming to the third line. So which is minus 11. So I press in minus 11. Minus 11. It's asking for B3 now. B3, which is this, 10. It's asking for C3, which is 0. I put in a 0 and my equals to. It's asking for D3, which is minus 2. So I put in minus 2 equals to sign. So that is how you use your calculator. So these are the values that I've just written out. So once you press it in your calculator or you solve it manually, so you're going to get your I1 to be 2.869 amperes, your I2 to be 2.956 amperes, and your I3 to be minus 1.043 amperes. So now we've been able to answer the first part of the question, which is find the current in each of the mesh. So we've gotten the current in each of the mesh, which is I1, I2, and I3. And by the way, if I'm speaking too fast, you can always slow down the speed of your video. That's if you're watching it on YouTube. Alright, so we've gotten I1, I2, and I3. Now, for us to get the currents in each of the elements, which is the next thing we are going to be doing. So I'm going to be using this space to explain that for us. Now, but before I explain that, if you look at what we are having for I3, we're having I3 to be negative. So that is to say that at this point in time, the direction we assumed here as a clockwise direction is actually anti-clockwise. So, but that doesn't affect our answer. It will just give us a positive value, but we indicate the direction. Alright, so let's do that. Let's look at the elements we are having here. We're having 1, 2, 3, 4. So for those elements that we are having here, let's find the current path flowing through them. So let's start with the current flowing through. So when I have something like this, I means current. So if I have it as a subscript, that is 1 ohm. So that means the current flowing through the 1 ohm resistor. So if you look at this circuit, this is the 1 ohm resistor here. The current that is flowing through it is I1. If you look at it, there's only one current flow, which is I1. So the current flowing through the 1 ohm resistor is I1. And if you look at it, I1 is given to, we've gotten our I1 to be what? 2.869 amperes. So that is it, the current flowing it. And the direction that we assumed is that, you know, when you are dealing with mesh, you always assume your direction. In most of my solutions, I pick clockwise direction. So that means the direction that we assume, which is a clockwise direction at this point, is flowing like this, you know, here, like this. That means to the right. That means the direction that we assume is actually correct. That means that is the actual direction that the current is flowing, because we are having a positive. So assuming we are having a negative value, that means it is in opposite direction. I hope that makes sense. So that is it for this 1 ohm. So let's go to the 10 ohm resistor. So current flowing through the 10 ohm resistor. Now in this 10 ohm resistor, there are two currents that are flowing through it. We have the current I1 and I2, because you can see it is between the two meshes here where we are having I1 and I2. So for us to get the exact value of the current that is flowing through it, we examine it. Okay, we have I1, we have I2. Let's go back to our answers. We have I1 and we have I2. So we look at it, which of them is higher between I1 and I2. So whichever one is higher will come first, subtracted by the one that is lower. So I2 is higher than I1. So with that, we are going to be having I2 minus I1, because if you look at it, I2 is 2.9, I1 is 2.8. So that will be 2.956 amperes minus 2.869 amperes. And what would that give us? So let me just type that in my calculator and see. So 2.956. And by the way, if you try to use your calculator to solve that simultaneous equation, and when you want to clear it, just press your shift mode and then 3. Press your 3 and then you press equals to 2 times to clear everything. Alright, so that's 2.956 minus 2.869. So that will give us 0.087 amperes. So that means the current flowing through it is 0.087 amperes. So for you to determine the direction, the direction will be with the the direction of whichever current that have the highest value. I2 have a higher value, so the direction of I2 on the 10 ohm resistor is what? Is upward, because like this. So this is how it will look like. So when it is flowing, and when it gets to I2, it is flowing upward. I hope that makes sense. Alright, so that is it for the 10 ohm. So let's look at the current that is flowing through the 5 ohm resistor. So the current flowing through the 5 ohm resistor is just I2 alone. So if you look at it, I2 alone. So let's say the value of I2 is what? 2.956. So that will be current through the 5 ohm resistor is I2, which is what? 2.956 amperes. Okay, so now let's look at the next element we are having is the 15 ohm resistor. So for the 15 ohm, so that means current flowing through the 15 ohm resistor. So if you look at that circuit, what is it? The current flowing through it is what? Is I3. So it's I3. And this time around, our I3 is negative, so we cannot just go ahead and write minus 1.043 amperes. It's not that you are wrong, but let's just do the right thing. So we are going to give it to be without the negative, so that's 1.043 amperes. Now for you to just prove that if you have solved something like this and you get a negative answer, and when you are indicating that a particular, when you've gotten a negative answer for a current, and then you're indicating that it's also passing through an element, and you take out the negative sign, you have to indicate something, which is the direction, like we are doing here. Okay, for this one I didn't indicate the direction for the 5 ohm resistor. Okay, so if you look at it, at this point it is flowing in this direction, so this is what it will be. So like I explained maybe in this video, in the last video, you know, one current can flow in different direction. Exactly, like this I2 on the 10 ohm is flowing upward, on the 5 ohm is flowing to the right. I hope that is clear. Alright, so let's come back to this. On this 15 ohm resistor, so is I3, which is a negative minus 1.043, but we don't want to have it a negative value here. And I said the reason why it's having a negative is because the direction that we assumed here, which is a clockwise direction, that means here we assume that the current is flowing downward, and that was why we got the negative answer. So now that we've gotten the negative answer, it's telling us that this current is not flowing downward, it's actually flowing what? Upward. Exactly. So what we are going to do now is, when we are now writing our answer for the current that is flowing through the particular element, we are going to have something like this. So instead of downward, we switch it upward so that we can have a positive value. I hope that is clear. If it is clear, do let me know in the comment section below. Alright, so that is it for this video. I hope you find value under the video SuperMesh. So this is what I want to cover so far under SuperMesh, and in the next one I'll be looking at nodal analysis. And I want to believe by the time you'll be watching this video, I should be done with that. I'll leave the links to everything in the description of this video. So if you have any questions under this or the previous videos I've done, do leave them in the comment section below. Do make sure you subscribe, give the video a thumbs up, share it with your colleagues, and do check out our website also, PE Academy. There are a lot of great content there. So peacademy.co, peacademy.co. So with that, I'll see you all in the next video. Thank you very much for watching.